I know as we're moving through this, we've been maybe for the first time thinking about sines and cosines and secants and cosecants and tangents and cotangents and all these identities and the ratios and relationships between them. We might be getting used to the words, but they just feel a little bit farther away from really understanding what they do. And that's natural. If I was in your spot where you're at right now, yeah, a lot of this would be, okay, this is new. I don't know if I can do it. And I just want to encourage you, hang in there. Because I know as you start to get into a little bit more, it starts to make sense a little bit more than it has in the past. Because again, we're looking at things that we don't really deal with that much in our algebra classes leading up to this. We're starting to learn about some new functions. And so, and with these trigonometric functions, we're going to start to unpack some new ideas. So hang on with us. I hope this will be helpful, and I think you guys can do it. So one other idea, and you may have already picked up on this, is that there's some relationships between some of the identities. And over here on my right side, I have 6 reciprocal identities, which means that the sine of theta, well, didn't we always see that the sine of theta and the cosecant were always the same numbers but reversed? And the same thing with cosine. Cosine was always the same numbers but reversed with secant. And tangent and cotangents were opposite. Or maybe opposite's not the right word. Maybe a better word is reciprocal. So we can develop some reciprocal identities that we can be aware of. You put them in our tool belt in case we ever need to use them to solve a problem or solve a complex problem. Along with these reciprocal identities, I also have some quotient identities, where the tangent of theta is the ratio of sine theta over cosine theta. And then cotangent is just a reverse of that, of the cosine theta over sine theta. So those are some identities that we could use or find helpful. So let's kind of look at how those may be helpful. I have 2 angles. Sine of theta equals 2/5, and the cosine of theta equals root 21 over 5. And I want to go ahead and find out what are all the trigonometric identities. One way I could do is I could just put those numbers back into a triangle and then recalculate everything. Or just for practice, because there will be times that using these identities will be more useful, let's get the hang of how to do that. So what I have is sine over cosine, and I have a quotient identity of tangent of theta. So tangent of theta equals sine theta over cosine theta. I know the sine of theta is 2/5. Cosine of theta is root 21 over 5. And then if I remember how to divide fractions by fractions, I can flip over and the 5's disappear, and I get 2 root 21. And then I have to rationalize the denominator in that case. So that's multiply both the top and bottom by root 21. So I get 2 root 21 over 21. So now I have sine of theta, cosine of theta, and now I have tangent of theta. And we'll do another one. Let's see if we can do cotangent of theta, which is cosine over sine. So the cosine is root 21 over 5, all over the sine, which was 2 over 5. I can either multiply the top and bottom by 2/5, or I can invert and multiply, and then I'll be left with root 21 over 5 over 2. And so now I have the cotangent of theta, which is root 21 over 2. So I have sine, I have cosine, I have tangent, I have cotangent. And then cosecant, well, cosecant's 1 over sine of theta, and sine of theta was 2/5. And so then that becomes 5/2. So now I have cosecant, and let's put that over here, that's 5/2. The tangent of theta to root 21 over 21. The cosine of theta was given. The sine of theta was given. So let's put those up there anyway. The cotangent we did over here was root 21 over 2. And the last one we have is the secant of theta. The secant of theta was 1 over cosine of theta. So 1 over the cosine of theta was root 21 over 5. Multiply down that now, that becomes 5 over root 21. To rationalize that, I need to multiply both sides by root 21, or top and bottom. So then I'm left with 5 root 21 over 21. Now, I know I skipped over a little bit some of the algebra we learned before as far as how to find the quotient of two fractions. So I know I skipped over that. If that looks like it was some magic that I did right there or some witchcraft, please go back and look at your previous notes and kind of do that and kind of unpack how you do that and how you rationalize the denominator as well. But basically, using trig identities, you can be given very little within a triangle, and you should be able to find out all of the other significant angles and identities within that particular triangle. Or at least that's our goal, to help you learn how to do that.